because a single mechanism fundamentally gives rise to both these noises. See, any attempt to minimize them simultaneously is not possible. So, for short channel, we assume mod C is going to be 0.395. Okay, so that is going to yield the minimum noise, and it is going to also ensure maximum power transfer. And that input impedance of MOSFET is infinity. So unless you match that to 50 ohm source, it is very difficult for you to apply maximum power transfer. So maximum power transfer is a very, very important a feature in RF circuits, and LNA should have both maximum power transfer and minimal noise. So whether you are going to go for power match or noise match, you have to decide what you are going to use. So one straightforward method of maximizing power and minimizing noise is 50 ohm termination. So you put a 50 ohm resistor across the input of amplifier, across the output of amplifier, so that the impedance maximization will take place. Otherwise, the maximum power transfer will not take place. You have loss of power, which may increase your noise. So adding a resistance R1 to your network. See here, I have a source resistance RL, I have a load resistance RL. So adding a resistance R1 will increase the thermal noise, will cause power loss, and it will attenuate the signal. And definitely this transistor is going to produce a high noise figure. So this is addition of impedance matching device is going to increase your noise of the network. And the noise figure is given here. F is greater than or equal to 2 plus 4 gamma by alpha 1 by gm into R. So our goal is assuming load resistance equal to source resistance equal to capital R. So only when all these conditions are satisfied, so the noise figure can be considered to be a decent one. Otherwise, you have to work a lot to minimize your noise figure. And whatever shunt series amplifier we have seen, that is also a very good example of amplifier which is going to have a reduced noise figure, because negative feedback is going to reduce the amount of noise. The shunt series amplifier, whatever we have seen, is the best amplifier for having a very reduced noise figure. So the amplifier sketched in the figure suffers from the fewer problems than the previous circuit, even though you have a lot of resistance here, but the negative feedback ensures that the noise because of all these resistance is going to be cancelled out. And also we don't have the impedance matching network, so the input impedance, if you measure, it will not be equal to 50 ohm. Output side you measure, it will not be equal to 50 ohm. So power match is not obtained ideally in this type of amplifier. Okay. So finally, when you compare power match and noise match, it is very difficult to say which one you require and which one you not require. And the beauty is you cannot match both. Matching power and matching noise is not possible simultaneously. Okay. And when you go for a broadband amplifier, use this when the LNA is going to be a broadband amplifier. Even though the power match is possible, the matching the noise or keeping the noise figure minimum is not possible. So one method of achieving that is going to use a common gate configuration, or it is similar to